Morning everyone, I hope you're all okay and have had lots of fun in the snow. Here we are ready for some maths on Tuesday. So let's start with our warm-up today. Now what we're going to do is have a look at some percentage calculations. The first two are just working out percentages of amount, and then the final two are working out the missing whole number. Now some of you worked on this yesterday, some of you did something a little bit different. If you haven't done this yet, just think carefully about what the missing number could be. If you've got a good idea of how to calculate it, then you can then work out the 50% of that whole number and see if it gives you an answer of 90. So pause the video, come back, and then we'll share some answers. Okay, so 15% of 60. Now, hopefully you will have thought to yourself, right, 15%, I need to know what 10% is and 5%, and then I can add those together. So 10% of 60, I divide by 10, so it gives me 6. 5%, I halve 10%, and so I get 3. So my answer for 15% of 90, if I combine those together, is 9. Now, 41% of 50, I need a couple of things going on here, don't I? I think really I need to know what 10% is of 50. So I'm going to do 50 divided by 10, which gives me an answer of 5. Now, if I then want to know what 40% is, well, from 10% to 40%, I times by 4. So I need to do 5 times 4, which is 20. Now I need 1%. We've done lots of this, so I divide by 100. Oh, excuse me. Now, if I divide 50 by 100, I'm going to get an answer of 0.5. So what have I got so far then? 40% I know is 20. 1% is 0.5. So if I combine those answers together, I get an answer of 20.5. Excuse me, I'm choking while I'm talking. All right, now number 3. I'm now looking at a missing number. Now with these ones, 50% of something is 90. Now that means really, can I use my inverse on this one? I think I can, because 50% is like saying half of something is 90. So surely if I go the other way and I double that, times it by 2, then I would get 180. Now half of 180 or 50% of 180 is 90. So therefore I know I am right. Now, in a similar way, how can I use the inverse to help me here? Now, whenever I see 25%, in my mind, I instantly think of a quarter. Now, that means 25% or a quarter of something is 20. Now, I find this one much easier to look at using a bar model, because what this means is that a whole number which we don't yet know has been split into quarters, and we know that 1/4 of this bar model is worth 20. Now, to make this a whole, because it's quarters, we've got to have 4 lots of this 20. So if I do 20 and I times it by 4, what do I get? I get an answer of 80. So that means that 25% or 1/4 of 80 is 20. Are we right? Yes, we are. So use your decisions here have got to be made where you've got to use your knowledge of percentages and fractions as to how you tackle those missing numbers, different ways of doing it. Now today we're going to be focusing on converting fractions into percentages, and we're going to, our will is that I can convert fractions to have a denominator of 100, because that way we can put it into a percentage. I can see the relationship between fractions and percentages, and I can interpret how much of a shape is shaded as both a fraction and a percentage. So let's have a look at our Discover today. Now we've got Jen and Toshi, and they are doing some painting. Now today they are painting a wall, and the question says what percentage of the wall is painted orange. Now we've done a little bit of this before. Now if I want to put this into a percentage and I want to know how much is painted orange, the first thing I've got to do is decide, well, how many parts is this wall divided up into? Now, if I count across the top, 1, 2, 3, 4, 5, and count down. 1, 2, 3, 4, 5. 5 times 5. So there are 25 parts to this wall. Now that 25, we all know, makes our denominator. Now, how many are shaded of the 25? We can just count them now, can't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that 10/25ths of our wall is shaded. Now, that's all very well because we've got a fraction there, but how am I going to convert that into a percentage? Oh, sorry, I've clicked on, I shouldn't have done. Now, if I want to look at this as a percentage, remember, what does percent mean? It means out of 100. Now, that means I've got to convert this fraction to become out of 100. So I use my knowledge here of converting fractions and think, right, what am I multiplying 25? How many groups of 25 are there in 100? Well, there are 4, aren't there? So I've got to times that by 4. And I've got to do the exact same then to the top. So I've got to times the top by 4. So that means that 10/25ths is the same as 40 hundredths. Now, if that's 40 hundredths, 40 hundredths is the same as saying 40%, because it's almost like as soon as your fraction is out of 100, that's the same as saying or using this sign percent, out of 100. So if you've managed to convert your fraction to be out of 100, you just need to pinch that top number and that is your percentage. Okay, now this time it says Jen and Toshi want to paint 30% of the wall yellow. Now, how many rectangles do they need to paint yellow? Now, there's a little bit of a clue here. It says the whole wall has 25 rectangles. So we need to find 30% of 25. Now, in order to find 30% of 25, how would we do it? Well, I think that we know how to do this now, don't we? So we would think, right, 25 divided by 10. Why am I doing this? I'm going to, first of all, aren't I, find 10%. So 25 divided by 10 becomes 2.5. Now, in order to find 30%, I've got to take my answer of 2.5 and I've got to multiply it by 3, haven't I? So it's got to get 3 times bigger. So 2.5 times 3 gives me an answer of 7.5. So that means I've got to shade in 7.5 rectangles. Let's see if we're correct. So here is the wall. This is the orange ones. Now let's see how many they've shaded. 1, 2, 3, 4, 5, 6, 7.5. We've got it right. So do you see there that if you're finding the percentage, we found 10% first, then multiply by 3 to find 30%. Now, these questions here are very common because you have to find, first of all, the fraction of the shape that is shaded before you can convert it into a percentage. So like we did with the wall, what's the first thing we're going to do? We're going to count how many squares this grid is divided into. So I'm going to go 1, 2, 3, 4 down, and 1, 2, 3, 4, 5 across. So that means the denominator for our fraction must be 20 because it's 5 times 4. Now, how many are shaded in? In green, 2, 4, there's 6, aren't there? So 6 out of the 20 are shaded. Okay, and we are agreeing with what they have said here. So we've got 6/20ths are shaded. Now remember, I can only put it into a percentage if my denominator is 100. So fortunately, 20 does multiply by something to become 100. Do we know what that is? Yes. Oh dear, sorry, this keeps popping up on here. So we've got to multiply 20 by 5 because 5 times 20 is 100. Therefore, I've got to do 6 times 5, which gives me 30. So 30/100ths. Now, remember what I said on the first slide here. As soon as your fraction is out of 100, you can get rid of that denominator of 100, and that top value, that numerator, is now your percentage. We couldn't do that from 6/20ths. some people make the mistake of finding the fraction and then they say, oh, that's 6% because my numerator is 6. Can you think why that's wrong? Why would that not be right? That wouldn't be right because their denominator has to be 100 in order for them to just use the numerator as their percentage. Okay, so then our final box here says how much of the grid is shaded? 30% of the grid is shaded. Okay, right, let's have a look at one more. So this time, see, we've got a new grid. So maybe pause the video and have a go. See if you can work through each step here. This one's a little bit harder, but if you want to have a go, then do that. Okay, so here's what I would do. First of all, I need to know how many parts there are to my grid. So 1, 2, 3, 4, 5, 6 times by 1, 2, 3, 4, 5. So this grid this time has got 30 parts to it. And how many are shaded? There are 3. Now, I've got a bit of a problem here because what I've said on the last few slides are, well, I've got to make my denominator become 100. Can you see the problem that I've got here? What is the problem? My problem is that 30 doesn't multiply by anything to give 100. And this happens quite a lot when we're converting our fractions into percentages. So if that is the case, if you can't directly multiply your starting fraction to become something out of 100, here's what you do. I am going to first of all think, well, 3/30, they're in the same times table, so they can be divided by a number that is the same. Therefore, what I'm going to do is I'm going to put 3/30 into tenths. In order to get this fraction into something out of 100, I've got to do 2 steps. So here comes step 1. So step 1 is I'm going to change my fraction to become something out of 10. So in order to do that, what have I divided my 30 by? I have divided it by 3. So that means I have to divide the top by 3. So 3 divided by 3 is 1. So 3/30 is the same as 1/10. Now, do you see what you have a thought about what step 2 might be? Well, step 2 is going to be the fact that now we have put our fraction into tenths, what can I now definitely put my fraction into? I can change it into hundreds because 100 is a factor of 10. I've got that the wrong way around. Excuse me. 10 is a factor of 100, which means it can be multiplied by something to give 100. So what can I times 10 by? I could do 10 times by 10 would give me 100, wouldn't it? So that means I've got to multiply my numerator by 10. So 10 times 10 is, 1 times 10 is 10, and down here we've already got it over 100. So what have we done here? So we've now said that 10 100ths, now we can get rid of that 100 denominator, pinch the numerator to make it 10%. So 10% of the grid is shaded. All right, so do you see that if you've got a denominator which can't be multiplied to give a denominator over 100, sometimes you might need to, because we've simplified that, haven't we? We've simplified 3/30 into tenths because we know that tenths can then be put into 100s and it will come out with the same answer. Now then, let's have a little look at this one here, this class survey. Now, actually can't see this very well at the bottom, can we? Because my bottom bits come up. So can you see at the bottom here, it says what percentage of each group voted yes? Now, class 4 has got 13 people voting yes. All right. Class 5 has got 15 people voting yes, and the staff have got 2 people voting yes. Now, the important thing when you have a question like this is that you total how many people have voted before we do anything. That's the same as just looking at a grid and thinking, how many parts has it been divided into? We need to know the total amount before we can work out any percentages. So for class 4, How many people here have had a vote in the first place? Well, we've got to do 13, add 10, add 2. Now that gives us a total of 25, doesn't it? This one in class 5, 15, add 9, add 6. Well, so 9 add 6, I would think that's going to give me 15, add another 15. So this one has a total of 30, and the staff has a total of 20. So now we have our totals, we can write our yes votes as a fraction. So in class 4, here I'll do it underneath so we know which one we're talking about. 13 out of the 25 people voted yes. In class 5, 15 out of 30 people voted yes. And in the staff, 2 out of 20 voted yes. Now, how am I going to represent these as a percentage? Well, I have got to make all of these fractions somehow become out of 100. Now, for this one and this one, the staff in class 4 is going to be one step. Maybe pause the video and see if you can have a go at putting those fractions, converting them to be a fraction out of 100, and then come back and we can have a look to see how you've got on. All right, so for class 4, 25 to get to 100 multiplies by 4, doesn't it? So what do we have to do to 13? Same as the bottom. We have to times it by 4. Now, I was having a couple of questions about this, and actually I was helping my daughter with something similar. And she was like, oh, I don't know my 13 times table. And I said, don't forget to use the methods that you know for other parts of maths. So what I mean by that is 13 times by 4, if you think I can't do that in my head, or I don't know that times table, use the column method that you know, and you use it all the time to help you. So 3 times 4 is 12, 4 times 4, 1 is 4, add 1 more is 5. So that makes 13 times 4 equal 52. So that makes this one 52 out of 100. Now, because we've got 52 out of 100, we can get rid of our denominator, and class 4, 52% of people said yes. Now, let's whiz over to the staff. Again, 20th, that can be converted into hundredths, can't it? By timesing by 5. So let's do the same to our top number, times it by 5, which gives us 10. 10 out of 100, get rid of our 100 denominator, which means in this case, 10% of people said yes. Now, finally then, let's have a look at this fraction here. We've got a similar problem to before where we had 30ths, but this time I can't make it into tenths, or can I? Can I make it into hundredths? I'm not sure. So what am I going to think here? Now, if you're a bit confused by this step about making it into tenths, I think sometimes just think to yourself, can I simplify it? Because you might find by simplifying, you actually get to tenths or fifths or 20th, something that will go into 100, even without realizing. Now, this can go into tenths, can't it? Because look, I can divide this by 3, and I can divide this by 3. And actually, we have simplified it a step. We've made it 5/10. Now, that way, because we're now into tenths, we can now convert that into hundredths, because we can times by 10, and we can times this by 10, and we get 50. So we've got 50 out of 100. Now, you may spot that actually, by looking at 15/30ths, you might have already said, well, I know that's the same as a half, which is 50%. And if that's the case, absolutely brilliant. If you didn't spot that, then you might need to use these steps to help you get to that percentage in a slightly more obvious way to help you see how to do it. Now, again, what we can do here is we can think, right, 50 out of 100, get rid of my denominator. So this equals 50%. So which grouping had the most yeses, we can say actually is class 4, didn't it? Even though class 5 had 50 people say, sorry, 15 people saying yes, class 4 actually had 13 people saying yes, but because it was out of 25, the percentage was actually higher, and so they had more people saying yes. Now, I am not going to go through each part of this, but if you are still thinking, oh, I'm a little bit still unsure with this type of question, you could have a go now at pausing the video and thinking, right, I'm going to work out the percentage of people that said no. Now, what you could do then is pause the video, think, right, this time it's 10 out of 25 for this one. How am I going to make that come out of 100? What's my percentage? And then have a go at doing the same for the other tables. If you're still a bit confused, you can always send me a message if you want a bit more help on this, all right? But it's good practice to maybe do that. And you could even do the same for the don't knows, all right? So for your work today then, you are going to be working in your Power Maths books. Hopefully we're all back at school today for those of us that are in school. So you've got your proper Power Maths books in front of you. If not, I will do the same and I'll have sent you the pages anyway, so don't worry. Now you're going to be working from pages 50 to 52. I've left the challenge up on the screen. If you want to pause it at the end and have a go, that's great. And send me photos of your work again. I hope you're all okay, and I'll see you again tomorrow. Bye-bye.